All right, captain of PHB created drop string. So we're going to take a string as the first argument and then take some characters as the second argument, and we will drop those characters from anywhere in the string. They don't have to be next to each other. So we've done, I think it was without or something. There are other challenges where we take off particular characters. This is not like that. So we have butterfly, and we want to take out the butt from the butterfly. It takes out all of those characters. Notice that T is only specified once here, but it's twice in the input. So anywhere that it extends the second argument, we wanna remove it. So walk me through like a
this one. I think I have a concept of I won't code, but let me comment here.
Okay.
So we have 2 inputs. We have T and U. T, which is our base string, and U, this is the removals. First, we want to create a union from or of the removals, because we want to know if a character from T can extend one of the characters from that union. This would be done through recursion, blah, blah, blahs.
I can give you one of those.
Yeah, cool. And then once we have that, we recurse through each character on, I can type as I talk, recurse over T if car extends union, drop, else retain. And that should do it.
Great. All right. I have a way to make it even easier, but it is exactly in line with the solution you're talking about. So if we have a union, like let's say, let's take this one out, but so test T and U. Let's do that. So let's do 3 things in here. So we'll do infer, I don't know, we'll call it L or left, whatever. And then we have U, and then do we need U to extend string? Okay. All right, let's grab these and put them on the next line. So if we do this, let's do like, I don't know, we'll put in left and right. This isn't the solution, but I just want to show something. Otherwise we'll return, like, oops, I don't know. So if we grab this test type and we say type x equals test, and we put in but as the delimiter, and let's put in B here. What we're going to see is that we get oops if we need to have multiple characters. All right, let me show you this. Okay, we're going to come back to this in a second. Let's do it in the case in the case of ours, and I'm going to show you like why it works. Maybe is better. So we can do T extends and do the same. In fact, I'll just copy this because it's going to be literally the same. T extends those 3 things, and we need U to say extend string. Okay. So here we're going to recurse because that's the only place we can, because we have the values. We know that much, so something's going to happen here. The base case, what would you put for the base case? I think it would be just T, because then we're done recursing. Yeah, okay. We'll see if
yeah, because we don't have anything to match.
Right, and then so we'll grab left and right here.
Right.
And then always the delimiter stays the same, so we'll pass it in that way. And if we do something like this, let's take a look at the challenges, like what happens up here. Oh, any. What did I do wrong? T, U extend string. Left, right. Huh. Okay.
You have on line 51 or
51.
Go ahead, sorry.
Oh no. Drop string. You got to take a big long gaze sometimes at this stuff.
Yeah, I'm just wondering if one of the types on 46 or 51, if like one of the statements isn't closed, although they look completed.
So okay, let's see what happens. T, let's give it a generic constraint just to be friendly. Infer left right. Excessive. Oh, okay. So it is sort of working. It's just it has excessive depth. Okay. All right. That's the error. Fine. Fine, TypeScript. We do see it sort of functioning, so that's fine. TER fly. Okay, let's take a different approach then. So if we're hitting recursion lengths, I'm gonna just show you one that I'm pretty sure works, and I think it's close to what you were saying or what we were working towards. So if we have t extends head tail, so this head is going to be just the first character because that's how it works in TypeScript. There's no good reason. It's just that's how it is. U extends, and then we're going to look through to see if there are 3 characters here. Any arbitrary, so if U extends any arbitrary like set of things, we want to grab that thing from the middle. And if there's nothing, like empty string is an option here. So this, this could be empty string there. If there were 2 things, it would suffice when we're recursing. Then we pass in the tail because, again, that's what we always have to do with the recursion is we're going to like keep building something up with the head, and then the tail is the part that recurses. So if there's no U left, then we just pass the whole thing in. But otherwise, we pass in a string that contains head and then recurses with the tail. So this part is the same. The only difference is that we're in the false case here. We're adding the head in because we found one. Otherwise, we didn't find one. So does this make a little sense? I hope, maybe.
Oh, it absolutely does. The only difference between it and what I was saying is it's on line 60, it's using that trick of the string has string to inspect.
Right. Let me see if we can refactor this one.
Other than pre-processing it to a union.
Let's see if we can. Yeah. Let's see if we can fix this one. So, drop string. Let's see. Oh, I know. Okay. You know what? We can just use this to drop the character. What if we did this? Drop. Let's rename this one. Let's rename this to drop the character, and then let's build a type that does the same sort of thing. So I think this will work if we do it like that, because that's really what it's going to do. Is it's gonna take that character out. So let's do drop string tu, and we'll put in the generic constraint if we have to. So u extends, and we'll do our normal infer head, infer tail, and then we can do DropChar here, passing in t and head, and then what is the base case going to be? I think it would probably just be t. So what's the error here? Cannot satisfy the constraint. Let's get rid of the constraint. Okay. Yeah, that works. So DropChar. So let's take a look at this. This is what I was trying to get to up here and couldn't think of it. But so if we want to drop a particular, let's just use DropChar since we have it. So if we want to drop, this is gonna be B. So did we do it right? Oh, it should be the other way around. B U T. It's just dropping a single character. So we want to drop B from anywhere in here and in the first character, in the first argument, and that's what DropChar will do. So it will recurse through the string and drop that character every time. Then, so this is kind of like what you said, create a union of the removals, and then for each removal, go through the whole string and remove it everywhere in the string.
Well, so I was thinking, like, if we take, so if we hover over X, we get the whole thing. So we see, like, UT, there's some Fs. So what I was thinking is, like, that, having that union.
Oh, that's interesting.
Then, I may have crashed TypeScript.
Oh, TypeScript is loading. Okay, never a good sign when it gets like that. Okay.
But yeah, I was wondering if that, I don't know if that works with that. Just using that union.
Maybe not. Yeah, although if it's like a union in there, will it die? I guess it's comatose. Yeah, loading. Okay. Well, it would be nice. Yeah, and we can use. I could grab it, but we could probably create a solution using string to tuple. I think is the name of the type that does this. There's a challenge for that one. But
like this is very TypeScript-y. So this is probably the better way and approach to do
This
it.
one, yeah. Yeah, this one doesn't
The actual solution that works.
Right. I don't know what the order of magnitude would be, but like this solution doesn't recurse through twice. Whereas this one recurses through the whole string for every drop character.
I mean, so does this, because TypeScript still has to process the type and evaluate it.
But once. Right?
But it's going through and it's looking at every character basically inside you. So if you're
because it's doing the distributive union,
N plus M, you still have
right.
But you're not doing the work anymore. So maybe better.
Yeah, maybe. Okay.
Better.
Well,
it is more effective.
All right. Well, that's enough for that one. Drop string. Good times in the hard difficulty set.